Hey everybody, welcome back. Today we're going to be talking about 3.5. We're going to be using equations, tables, and graphs, and we're going to be coming up with each of those three. So given a table, can you come up with a graph and an equation? Given an equation, can you come up with a table and a graph? Given a graph, can you come up with an equation and a table? Yada, yada, yada. Woohoo! Hope you're excited. I hope you're ready to go. Let's get back to math. Okay, so we are going to be learning to generate different representations of the exact same data. And that's between equations, tables, and graphs. Let's go. Okay, so the very first thing I want you to do is, given this equation, we've talked about this before. Given this equation, what I want you to do is make a table, and I want you to sketch a graph using the equation of y equals negative 2x plus 3. And what I want you to do is I want you to come up with at least 4 points. Come up with 4 points on your graph to come up with this problem. All right? So 4 points. So pause now, make a table, and sketch the graph. Go! All right, so remember, we get to come up with our own points for x. So here's our table. It looks like this. And then we have our x's. I am going to use negative 1, 0, 1, and 2. Again, use 4 points. So what I do is I plug in negative 1 in for my x. Y equals negative 2 times negative 1 plus 3, because that's exactly what my x is. When I take negative 2 times negative 1, I get positive 2 plus 3. My answer is 5. And my equation, the number I plugged in, my input is negative 1. My output, or my y, was 5. All right, so I'm going to do that same thing. Now, you may not have used the same 4 points, and that is okay. Your graph, however, should be in the exact same position, maybe just a little bit different of points. So when I look at this, when I fill out my table, your graph should look very, very, very similar to mine. All right, so here's my finished table. And it looks like that. Again, I just plug in 4 points that I come up with for my x, and plug them in and get my y. Remember, your x is known as your input. Your y is known as your output. I need to plug in my x to get out my y. All right? So when I graph this problem, I graph at negative 1, 5, negative 1, negative 1, up 5, 1, 2, 3, 4, 5. Next one is 0, 3. 1, 2, 3. 1, 1. And 2, negative 1. And I would draw my line just like this. And my graph would look like that. And I'm done. I made a table. Check. I've sketched my graph. Check. I'm done with the problem. Check. With a little smiley. Awesome. Sweet. So again, your graph might look slightly different. If you use 3, your next point would be right here. If you use 4, your next point is right here. It would just keep going on in that same direction. Awesome. Now, what we are going to do is we are going to use the table to make a graph, and then we're going to write an equation. Okay, this is the tough piece, to write an equation. Okay, the very first thing is we're going to make a graph. So I'm given an x and a y here. X and y, x and y, x and y, x and y. So on the very first one, I have a point of 0, 3. I have a point of 1, 4. I have a point 2, 5. And I have point 3, 6. All I'm going to do is graph them. I'm going to graph in between them. So I'm going to plug in 0, 3, and my graph will look like this. 0, 3, 1, 4, 2, 5, and 3, 6. Just like that, my graph is going up and to the right. Now the tricky part, write an equation. Okay, so we know how to graph points. We learned that back in an earlier section of chapter 3. We know how to do that. We can manipulate the table by giving those points, and that's what our table does. It gives us those points. However, our equation is a little bit different. What you need to see is you are looking for a pattern here. Okay, what is the pattern that you are, that is going into? Okay, for instance, how do I get from 0 to 3? How do I get from 1 to 4, from 2 to 5, from 3 to 6? Sometimes they will have more than one equation or more than one operation happening. Okay, so be aware of that. This equation, we are always going to use x and y. So something is happening to x to get to y. We always start off with y equals. Y is going to equal, and when you look at each of those things, do you notice the pattern? In order for me to go from 0 to 3, then from 1 to 4, then 2 to 5, and 3 to 6. What is that pattern? Well, I'm adding by 3 each time. Every time I plug in an x, I add 3. So my equation when I do this, I need x plus 3. In my equation, I need a generic statement, which is exactly what an equation is, of I need a y and I need an x. Okay, need a y and I need an x. And what that tells me is if I plug in any number for x, I can get out a y, and I'm able to solve for that. Okay, any number uses that same rule according to this table with that equation given up at the top. I can plug in any number and I will get out a y. Okie dokie. Artichoke. So the next one that you're going to do is going to be very similar to this. Using a table, you're going to create a graph, which is the first and the easier section of this. However, I also want you to come up with an equation. Think of what's happening. Try to find a pattern from how you get from x to y, and it should be the exact same way every single time. If it's not the same, you're going to be doing something different, all right? So what I want you to do, okay, this line should be over here slightly. Okay, so it's, if I looked at my y coordinates, it is 1, 0, -1, and -2. I want you to look at my x, figure out how I got my y, and then write an equation, sketch the graph. So pause now, try this one. All right, so now when I look at this, when I'm sketching, my points here would be -1, 1, 0, 0, 1, -1, 2, -2. Okay, so now when I graph this point, I am going to plug in -1, 1, 0, 0, 1, -1, 2, -2. My graph looks like this. Okay, now, if I look at this, how do I come up with an equation? Remember, I'm always going to have an y is equal to something is happening to x. If I look at this, well, if I look at -1 to 1, how do I get from -1 to 1? Well, I could add 2. If I add 2, okay, if my equation is y equals x plus 2, that should work for the second one. 0 plus 2, is not 0. So this equation up here does not work. Okay, so we got to erase, start all over, all right? So after we erase, we're doing this problem. Okay, so as we do this, all right, as we do this, now we're going to start again with y equals with our x. Now, how else could I get from -1 to 1? Remember, it's not always adding. It's not always subtracting. It's not always multiplying. It's not always dividing. However, it can be one operation. So think about it. Remember a positive and negative. So how else could I get from -1 to 1? Try to tell somebody, how else could you get from -1 to 1 besides adding 2? Well, we could take this and we could multiply this by -1, right? -1 times -1 is a positive 1. Okay, that works. Okay, so that works for this one. What if I plugged in 0 here for x? 0 times -1? 0. All right, that worked for the second one. What's 1? I'd plug it, if I tried this 1, if I plugged in 1 here, what's 1 times -1? It's -1. So far, so good. Let's try it. Hopefully this works for the last one. What is 2 times -1? It's -2, absolutely. So if you look at that, my equation is y equals x times a -1. Another way to write that is y equals a -x. any number that I'm plugging in, I get a negative x on that one. Okay, so be careful. Watch to see what you are doing. Remember, you are plugging in numbers into this equation. It's a pattern. We've talked about patterns before. It's a pattern to go from to plug in your x, something happens, and out pops your y. All right? Awesome. All right, so now we are given a line. We're given a graph, and what we have to do is make a table. Okay, so here's our graph line. I try to make those lines nice, or those points nice and big for you to see. All right, so now when we do this, we are going to come up with a table. All right, so my table is going to look just like it did on the last problem where I have an x and a y, not the huge long table because we're not given an equation. We're going to come up with an equation. So I just have to come up with this. Now, 4 points there. As I do this, okay, my very first one right here, I start at the bottom left. If my x was 0, my y is -1. Next point, which is right there. My x is 1, my y is 1. Next one, plug in, which is right here. My x is 2, my y is 3. Next one, which is at the very top. Okay, I'm going to go on this side. My x is 3. My y is 5. Okay, so I came up with my table, and all my table was my points. Now what we have to do is we have to come up with an equation for this. All right, so how do I get, and again, how do I get from 0 to -1? Remember, it's not always just one simple equation. Okay, so if I were to test this out, 0 to -1, well, how could I get from 0 to -1? Well, I could take 0 minus 1 and I get -1. All right, so my equation would have been y equals x minus 1. Does that work for the second one? If I plug in 1 here, right here, okay, I'm plugging in 1. Do I also get 1? All right, so if I plug in 1 to this equation, I get 1 minus 1. 1 minus 1 is not 1, so that doesn't work. Can't just subtract. All right, so we're going to try something new. So x minus 1 doesn't work. How else can you get from 0 to -1? That's tough. How else? Try to think about that. How else could I get from 0 to -1? Remember, it doesn't have to be always one equation or one operation. Okay? If you're stuck on that one, how else could I get from 1 to 1? Well, I could multiply by 1. 1 times 1 is 1. Okay, but 0 times 1 is not -1. Okay, so we got to start over. How else could I get from 2 to 3? Well, I could add 1, but it doesn't work for the other two. It's got to work for all of them. The last way to do this, well, what if I multiplied by 2, and then if I took the 2, and then I multiplied by 2 to get to 4, but then I subtracted 1 to get back to 3. Would that work? Let's try it. What's 3 times 2, which is 6, minus 1? 5. Oh, everybody might be onto something. 1 times 2 equals 2 minus 1. Oh, I think we're onto something. 0 times 2 equals 0 minus 1. I think we got it. Okay, when you look at this, what did I do to my x to get to my y? Okay, y equals, remember, always, y equals. And we multiplied by 2, 2 times x, then we subtracted that answer minus 1. So my equation is 2x minus 1. And if you look at this, okay, if you look at this, the pattern from -1 to 1, from 1 to 3, from 3 to 5, you notice they go up by what? 2! They go up by 2. Also notice that the number that's multiplying by x is 2. So check to see if there's patterns there. All right? All right. That one was tricky. That's a 2 a two-operation equation. Okay, so let's try one on your own. I want you to pause now and come up with an equation to this problem. And our points should look like this. This should be right here. This should be right here, and right here. Okay, so I want you to see if you can write a table and an equation. So pause now, write this down. All right, so when you look at this, what are my points? Well, this very first point, I'm going to start at the bottom left. That is going to be -1, negative what? 5. Be careful here. Look, if you look at this lesson right there, that tells me it is -5, not just -2. Watch your scale. My scale is a little different there, so be careful. All right, next one. What is it? 0, 0. Okay, next one. What's my x? 1, 5. Last one. What's my x? 2. My y? 10. Okay, now what we need to do is come up with an equation. So we're going to write an equation for this. Again, we're always going to have our y, and it's always going to equal to something happening to x. All right, so you may ask yourself, how do you get from -1 to -5? Okay, well, we could take this and we could subtract 4. Okay, so if you think it's subtract 4 right there, which is true, go to the next one. Does subtract 4 work for 0 to 0? 0 minus 4? Nope, doesn't work. So subtracting 4 doesn't work. Okay, how else could you get from -1 to -5? Multiply by 5. What if I took, so multiply by 5. Okay, what if I took 0 multiplied by 5? I get 0. Perfect. What if I took 1 multiplied by 5? Oh, I get 5. What if I took 2 multiplied by 5? Hey, I get 10. Does this work? You betcha. You betcha. Absolutely this works. So your equation is y equals 5 times x. Again, you're looking for a pattern between your x's and your y's. Looking for a pattern. I also want you to notice this. As you're going down, you're looking for a pattern between your x and your y. But look for the pattern as I go down my y's. What is happening each time? I'm going up by 5. Guess what? That's what I'm multiplying by. Remember last time? My y's were going up by 2 and I was multiplying by 2. Now I'm going up by 5 and I'm multiplying by 5. There might be a pattern there. Okay, so that's all I have for you today. Today was 3-5. I hope you enjoyed equations, tables, and graphs, and mixing in between them. All 3 of them. So what I want you to do right now is I want you to go and have a great night. Maybe do a little math on your own because everybody loves to do math. Okay, enjoy your night. I will talk to you later. See you tomorrow. Bye.